Welcome back to the deep dive. So if you've ever tried using an AI chat agent for, a complex task, like maybe writing some code or trying to fix a tech problem,
Yeah.
you probably know the pain. You give it an instruction, maybe it's a bit vague, and the agent just confidently gives you something that's completely wrong, and then you're stuck clarifying for ages what you really wanted.
That gap right there between what you ask and what you actually need, that's the huge deployment problem for LLM agents right now.
Right.
Because real users, well, they almost always give what this research calls underspecified instructions. Like you said, maybe fix the server, a get network is unreachable.
Yeah, something short like that.
But they leave out critical stuff like which config file, what's the setup environment, all that context.
And the current big AI models, the GPT-5 level ones, they're really just optimized for one thing, aren't they? What we call productivity.
Exactly. Just rushing to finish the task based on whatever vague input they got first.
Ignoring the actual conversation needed.
Yes. They ignore the quality of that conversation, the back and forth needed to actually get the right info, and that just leads to failure, or just as bad, a really frustrated user.
Okay, so today we're diving into some new research that's trying to fix this. It's trying to train agents to be, smart collaborators, not just speedy task doers.
That's the goal.
We're looking at a new framework they call PPP, and this simulation environment called USERVILLE. The idea is to get past this interaction bottleneck. It's not just about task success anymore.
No, it's about conversational success too. It's really a shift in thinking about what makes an agent good. They lay out these three critical dimensions. They have to work together. That's the PPP, productivity, proactivity, and personalization.
Okay, so productivity, the first P. That one sounds straightforward. It's just, can the agent actually do the job?
Pretty much, yeah. You measure with standard things like F1 score or EM score. Basically, how accurate and complete is the final answer compared to the right one.
Right, P1 is the base. But P2, proactivity. That sounds like where the strategy comes in.
It is. This is the agent's skill in asking the right clarifying questions when it needs to. But, and this is key, avoiding the pointless ones that just annoy the user.
Knowing when to interrupt, basically, and when not to.
Exactly. It has to figure out what information is truly missing. What are the real blockers?
And then P3, personalization. This feels very human.
It is. It's about the agent adapting its communication style. Right. The tone, how brief it is, even the format of the questions it asks to match who it's talking to. Because your preferences might be totally different from mine.
Right.
Yeah.
Totally. So how does this PPP idea stack up against what we have now, the current big models?
Well, the need for it becomes super obvious when you compare. Like take a GPT-5, give it a perfect detailed prompt, and sure, it gets a high productivity score, P1.
Right.
But give it that vague, real-world prompt. It tanks on proactivity and personalization. It just doesn't know how to handle the ambiguity gracefully.
And the study had some numbers on this, didn't it, that really showed the difference?
Oh, absolutely. Get this. The agents they trained, specifically using this PPP approach, they saw, on average, a 21.6-point improvement on their combined score compared to those strong GPT-5 baselines.
Wow, 21.6 points. On complex stuff, too, like software engineering tasks.
Yeah, and deep research tasks. It's a huge practical jump. It really shows that this kind of, social intelligence is actually key for technical success, too.
It turns the agent from just a tool into more of a partner.
A robust collaborator, yeah, instead of something brittle.
Okay, but training this, all that back and forth, the nuances, it sounds like a nightmare to get the training data. You'd need thousands of people interacting, right? Giving feedback. That seems impossible.
Totally infeasible, yeah. Time-consuming, expensive. So that's where they got clever with USERVILLE.
The training sandbox.
Exactly. It's an interactive environment, but it's filled with LLM-based user simulators, not real people.
Oh, okay.
This lets them train and evaluate really fast at scale. You take the human bottleneck out of the training loop itself.
So the agent learns by talking to digital ghosts of users, essentially. But wait, does that work? Isn't there a risk it just learns to please the simulator LLM and not a real, unpredictable human? How'd they make it realistic?
That was definitely the main challenge. How do you make the simulation good enough? They tackled it in 3 main stages when building USERVILLE. First step, making sure the agent didn't start with perfect information. They called it prompt Vaguenization.
So making the input deliberately fuzzy.
Precisely. They took standard benchmarks, which usually have really precise instructions,
Right.
and used another LLM to automatically make them vague, like a real user might phrase them. So a super detailed bug report might become just time series. Removing column gives confusing error.
Leaving out all the crucial details.
Yeah, the core request is there, but the context is gone. That forces the agent to be proactive to ask questions.
Clever. They manufactured the ambiguity needed for training. What was stage 2?
Stage 2 was preference-aware user simulation. They didn't just have one type of simulated user. They defined a whole pool, 20 different interaction preferences.
20, wow.
Yeah, really diverse.
Yeah.
And they built these preferences into the simulators. So the agent has to learn to handle lots of different communication styles. It can't just learn one way of interacting.
And these preferences sound fascinating. You mentioned they show the complexity. Can you give some examples? What kind of things did they model?
Oh, they got pretty specific. Some were simple, like a user simulator might only answer multiple choice questions. So the agent has to learn to frame its question like, is it A, B, or C?
Okay, makes sense.
Others were much trickier. One preference demanded the agent ask at least 3 questions before trying to solve the problem. Another one, this is great, required the question to be in Italian.
Only Italian.
Italian only, seriously. That really tests adaptability, not just tweaking the tone a bit.
Exactly. Or it could be structural things like the user demands the question contain no commas, or that the entire question has to be wrapped in valid JSON format. Wow, okay, so that forces the agent to fundamentally change how it communicates, not just what it says. That builds real confidence it's learning a general skill.
Right. It's not just memorizing responses for a few scenarios. And then the third stage ties it all together. User-centric evaluation. This provides the actual feedback signals for learning proactivity and personalization.
So how do you measure something like proactivity? It feels subjective.
They came up with a clever metric, user effort estimation. The agent basically gets penalized based on how much work its question makes the simulated user do. The goal is minimal user effort.
Okay, makes sense. What were the levels?
So the best case is low effort. This means the question was necessary, but the answer was easily available from the information in the original precise prompt before Vaguenization. It's a small penalty because the info was there, just hidden by the vagueness.
Right, a good clarifying question. What about medium?
Medium effort is when the agent asks a bad question. The user simulator basically says, I don't know, refuses to answer, it was poorly posed, or just unnecessary, wasted the user's time.
Okay. And the worst, high effort.
That's when the user has to go above and beyond. They need to find information outside the original problem scope, maybe do extra debugging or read docs.
Yeah.
Just answer the agent, big penalty. But, and this is crucial,
Yes.
a session also counts as high effort if the agent just jumps to a wrong solution without asking anything first.
The penalty for being overconfident and lazy.
Exactly. By guessing wrong, it forces the user to do all the work of finding the error and explaining why it's wrong. That's high effort for the user.
That seems like a really comprehensive way to measure it. Rewarding good questions, punishing bad ones, and punishing lazy guessing.
It covers the bases. And for personalization, it was simpler. Just a small reward bonus, like plus 0.05, if the agent perfectly followed the user's preference, like asking in Italian or using JSON.
Got it. Measures that style alignment.
Ensures the agent learns that user comfort matters too.
Okay, so we have the PPP goals, the USERVILLE training ground, these smart evaluation metrics. Now, the training itself, they used multi-objective reinforcement learning, or RL. Can you break that down simply?
Sure. It just means the agent isn't learning based on one goal, like just task success. It's learning based on several goals at once. They created a combined reward. The total reward R is the sum of the reward for productivity, our prodder, plus proactivity, our proact, plus personalization,
Our prodder plus our proact plus our pers.
Right. So the agent is forced to figure out a strategy that balances all three. It has to learn the trade-offs. You can't just maximize speed if it means asking terrible questions or ignoring user preferences.
And when they actually tested this system, the results really highlighted why interaction matters so much, didn't they? That interaction necessity point.
Undeniably. When they took agents, gave them the vague prompts, but then prevented them from interacting, basically forcing them to rely only on P1, productivity, the task success score plummeted. It went from around 64 down to 44.
Huge drop.
Huge. It just proves interaction isn't some nice-to-have feature. For handling real-world ambiguity, it's absolutely essential. And letting the PPP-trained agents interact brought that performance right back up.
And they also did those ablation studies, right? Where they removed parts of the system to see what happened.
Yeah, classic validation technique. So for example, they trained an agent with the productivity and personalization rewards, but without the proactivity reward, our PROACT.
And what happened?
Predictably, the agent got much worse at asking good questions. Its proactivity score dropped significantly. It proves that each objective, P1, P2, P3, is critical. You need all three working together.
Okay, that makes sense. And this led to some really interesting behaviors, right? The agents learned to be quite strategic about when to actually ask questions.
Yes, that was fascinating. The PPP-trained agents developed a high ask ratio, meaning they asked questions frequently, but only when the prompts were vague. When they got a precise, detailed prompt, the ask ratio was very low. They learned not to bother the user unnecessarily. Ask only when you genuinely lack information.
That's smart. Minimal disruption. So that brings us to maybe the coolest insight. The difference between question quality and just question quantity. Teaching the agent how to ask, not just that it should ask.
Exactly. If you look at Figure 7 in the paper, you see this learning dynamic. Early in training, the agent starts asking more questions overall, realizing, okay, interaction gets me rewards.
Right, it experiments.
But then, as training goes on, the total number of questions kind of levels off, or even dips slightly, becomes more efficient.
But the type of questions changes dramatically.
That's the key. The number of low-effort questions, the good targeted ones, consistently goes up. But the number of medium-effort and high-effort questions stays low. The agent learns to zero in on the ambiguity efficiently.
And what about the agents trained without that proactivity reward?
Well, they showed the opposite pattern. They became, well, lazy interactors.
Lazy? How so?
They increasingly relied on the user. Their rate of asking medium and high effort questions actually went up over time. They basically learned to just dump the hard work of clarification back onto the user simulator.
So the PPP model learns the skill of effective questioning, while the other just learns the habit of asking, often badly.
Precisely. It's a much more sophisticated, useful behavior.
And this skill generalized pretty well, even to tougher challenges.
Impressively so. They tested it on this really complex task called SWE-Full. This involves actually editing large code bases to fix real bugs. It's hard.
Yeah, it's non-trivial.
And the PPP agent significantly improved the success rate there from about 0.29 baseline up to around 0.36. That's a meaningful step towards practical code automation.
And it generalized to preferences it hadn't seen during training, too.
It did. They held out 8 of the 20 user preferences during training. Things like the JSON format requirement or the Speak Italian one. The agent still performed well on those unseen preferences.
Suggesting it learned the general principle of adapting, not just memorizing the 20 training examples.
Exactly. It learned preference compliance as a concept.
So wrapping this up, what's the big takeaway here for building better LLM agents in the future?
I think the main message is clear. We can't just keep optimizing for raw capability or speed alone. If we want AI agents that people can actually trust and rely on for complex real-world tasks, we have to build in this user-centered interaction intelligence, making proactivity and personalization first-class citizens alongside productivity. That seems to be the path forward for truly useful AI collaborators.
That makes a lot of sense. It really shifts the focus. And, thinking about that personalization aspect, it does raise some interesting, maybe slightly tricky questions, doesn't it?
Oh, definitely. The ethical side.
Right. If these agents get really good at adapting to very specific, maybe even quirky user preferences, how do we make sure we understand how and why it's adapting? We need transparency there, right?
That's a huge challenge. If the adaptation is happening constantly under the hood based on subtle cues, we need guardrails.
Because you wouldn't want the optimization for, say, efficiency or making the user feel good to somehow reduce the user's own thinking or agency, or create this weird over-reliance.
Exactly. Personalization is powerful, but it needs to be transparent and accountable. The interaction has to remain genuinely helpful and empowering for the human, not just efficient for the system.
A really important point to consider as these agents get smarter. A fantastic thought to end on. Thanks so much for walking us through this deep dive into making AI a better conversational partner.
My pleasure. It's fascinating work.